We started the new chapter, aldehyde ketones and carboxylic acids. It is having 8 marks with option. Without option, it is having 6 marks. So this is the one of the important chapter in organic chemistry. Which is having the highest weightage. So yesterday we completed what is meant by aldehydes, what is meant by ketones, the definitions of aldehydes and ketones. Then the IUPAC nomenclature system of aldehydes and ketones. All this part is completed. Just we will take a quick review of the yesterday's part. What is meant by aldehydes, what is meant by ketones, what is the functional group, what is the difference between aldehydes and ketones. We will take a quick review and then we will start the next part. So just I want to repeat one important thing. What is the difference between aldehydes and ketones? Both these are carbonyl compounds. See in this figure, I have shown the one is aldehyde and one is ketone. Always remember the aldehydic group is present at the terminal carbon. And this is COH, means to this carbonyl carbon, one R group or AR group will be attached, and to the one side hydrogen will be there. So the functional group of aldehyde is COH, and the functional group of ketone is only CO. To this CO, both R groups will be attached. It will be same or it will be different depending upon the number of R groups, or depending upon the R groups or AR groups. The aldehydes and ketones are classified as aromatic and aliphatic ketones. If the R group is attached, it will be aliphatic aldehydes. If the AR group is attached, it will be aromatic aldehydes. So this part is yesterday already we completed the definitions of aldehydes, ketones, the classification, simple and symmetrical ketones, aromatic ketones. So all this part is completed. I hope daily you are reading whatever the notes I have given, and you are making the practice at your home, because this is organic chemistry. This is a volatile. If you didn't repeated this daily, it will be volatile. So my kind request, daily at least give 30 minutes to the chemistry, so it will be easy for you. Homeworks, yesterday's homework, many students send me the snapshots or scan copy by mail, but only 20 students send me this by mail. Remaining student didn't send. So this part yesterday already completed, and we will start from from unsaturated hydrocarbons. Yesterday we stopped here. I was explaining the reaction by hydration of alkynes. This reaction is important for JEE, NEET and CET exam. Remember, I will explain again. Alkynes, you know, this is a carbon-carbon triple bond. Alkynes react with water in presence of 40% H2SO4 and 1% HgSO4. They give the aldehyde ketone. This is a two-step reaction. In the first step, see, at the temperature 333, the water molecule is added across the alkyne. One hydrogen is added to any of this carbon because this is symmetrical. If unsymmetrical alkene is there, then we have to apply the Markovnikov's rule again. So first we will take the example of ethane here. The hydrogen will be added to one carbon, any of this one carbon, and OH will be attached to another carbon. We will get this intermediate first. So after forming this intermediate, after isomerization in this, hydrogen is shifted. Isomerization means the compound having the molecular formula is same, but the structural arrangement is different. Such type of phenomenon is called as isomerization. Tautomerization is one of the method of the isomerization. The hydrogen is shifted. See, the hydrogen attached to OH is shifted here, and the molecular formula doesn't changes. So isomerization takes place, and we get here ethanol. So another example is given here, propane. In this example, we have to apply the Markovnikov's rule because the hydrogen is positively charged and OH is minus negatively charged group. According to the Markovnikov's rule, is attached to the carbon atom which contains less number of hydrogens. So OH will be attached to this second carbon, because there is no any hydrogen is attached. And again tautomerization we get here propanone. So remember this reaction many times asked for board exam, sorry CET, the NEET and JEE exam it is asked. Now the name reactions are started. These are the methods of preparation of aldehyde ketones by using acyl chlorides. Acyl chlorides are also called as acid chlorides. One example we will take. The name of the very famous reaction is called as Rosenmund reaction. So what is this Rosenmund reaction? I will explain. This is a reduction of acyl chlorides. Acyl chlorides, these are also called as acid chlorides. These are hydrogenated, means these are reduced by using the catalyst H2. It is hydrogenation, and the catalyst is palladium, which is poisoned. Poison means some what you can say, reactivity of the catalyst is decreased by using this barium sulfate. This process is called as poisoning of catalyst. So in this reaction, the catalyst palladium is poisoned with barium sulfate, and the name of the reaction is called as Rosenmund reaction. We can use the aromatic acyl chloride or aliphatic acyl chloride. By using this catalyst, we get RCOH. So this is the name reaction which is discovered by the scientist Rosenmund. One example is given here, benzoyl chloride. You know this is a benzene and COCl, it is a benzoyl. This benzene and CO is benzoyl, and this is the benzoyl chloride. In presence of catalyst H2, BDSA4, we get benzaldehyde. We can take any example. We can take here acetyl chloride, they give acetaldehyde. So the aromatic acyl chloride is used, we get here aromatic aldehyde. So this is famous reaction, very important, many times asked for board exam for 2 marks, Rosenmund reaction. Then Rosenmund reaction, by using this Rosenmund reaction, we can prepare only the aldehydes. For the preparation of ketones, we have to use the cadmium chloride. So ketones are obtained by using acyl chloride by the reaction with dialkyl cadmium. So this dialkyl cadmium first, which is prepared by using reaction of cadmium chloride with Grignard reagent. First, we have to prepare this dialkyl cadmium. So you know this Grignard reagent, it is very famous, RMGX. In the chapter number 10, halogen derivatives, we already learned how this Grignard reagent is prepared. It is prepared by using magnesium metal with alkyl halides by using dry ether by Victor Grignard, the name of the scientist who prepared this reagent. It is very famous, RMGX plus CdCl2. CdCl2 is cadmium chloride. We get here dialkyl cadmium. This is dialkyl cadmium, R2. It is from the Grignard, and this is a byproduct. We will take directly one example. This is the ethanoyl chloride. So this is ethanoyl chloride because two molecules we have to take here. This is the dimethyl cadmium. It is prepared by using the above method by using Grignard reagent. Now see the reaction. Propanone is formed. The common name of the propanone is acetone. See how it is prepared. Two molecules of this CH3 from the acyl chloride, and these are the two molecules of methyl group from the dialkyl cadmium. They will combine and we get the byproduct CdCl2. So this is one of the method. By this method we can prepare the ketones by using acyl chlorides. Make a practice at your home. You can take the different examples here. You can use the different chlorides and we will prepare the different ketones. One more example is given here, benzoyl chloride. Benzoyl chloride plus dimethyl cadmium. Reaction is same. Two molecules we have to use because we are using here two molecules of cadmium. Then preparation of aromatic ketones by using acyl chlorides. This is Friedel-Crafts acylation reaction. In 11th standard, we already learned this reaction. This is a simple benzene plus RCOCl. This reaction I have taken from the 11th standard textbook. Benzene plus RCOCl. This is any acyl chloride we can take. If you take the acetyl chloride, we will get the acetophenol here. See, these reactions are completed in chapter number 10 also, in chapter number 11 also, in ethers also, in phenols also. So the Friedel-Crafts reactions, there are two reactions, Friedel-Crafts alkylation, in which alkyl chloride is used, and Friedel-Crafts acylation, in which acyl chloride is used. So this is a reaction with benzene. Substituted benzene also gives this reaction. So that's why it is given in the explanation. Aromatic ketones are prepared when benzene or substituted benzene here. Substituted benzene word is used, means benzene or any substance which is attached to benzene can give these reactions. So one example is given here, benzene plus acetyl chloride. So CH3CO is electrophile. These are electrophilic substitution reactions. Once again, I'm going to explain. Electrophilic substitution reaction in which halogenation is there, nitration is there, then sulfonation is there, and these are the very two, Friedel-Crafts alkylation and Friedel-Crafts acylations. So purposefully I have shown here right hand side how the electrophile is generated. This is also explained in 11th standard. CH3COCl, this is acyl chloride plus AlCl3. It is used as a catalyst. The role of the catalyst is in this reaction is to generate the electrophile. So this is the CH3CO is electrophile, which is directly bonded to the benzene ring. This part is actually completed in 11th standard, but for the knowledge purpose, I have shown here how the electrophile is generated and how we will get the product. Then, by using preparation of aldehydes and ketones by using cyanides or nitriles. You know what is meant by cyanides and nitriles. CN group, it is called as cyanides, or it is also called as nitriles. The name of the reaction is Stephan reaction, remember. In case of Rosenman reaction, acyl chlorides, say, in case of Rosenman reaction, acyl chlorides are converted into aldehydes, and in case of Stephan reaction, cyanides or nitriles, these are converted into aldehydes. Don't make confusion in between the reactions, because all these reactions are the methods of preparation of aldehyde ketones by using different compounds. So we will take one example and we will discuss. Stephan reaction is a reduction reaction, nitriles. See one example, we will take general reaction. This is any alkane nitrile. Any alkane nitrile RCN. It is any general, we can take any cyanide or any nitrile, which is reduced. These two hydrogen indicates the reduction reaction is there, and this is a specific reagent. It is used for Stephan reaction, which is stannous chloride, SnCl2 and HCl. This is a combination of stannous chloride and HCl. We get imine hydrochloride first. Imine hydrochloride intermediate we will get first. I will explain how this imine hydrochloride is prepared. So out of these two hydrogens, one hydrogen reacts with this carbon, triple bond is converted into triple bond. This will be N minus, and again one hydrogen is added here, and the HCl is in vicinity. Actually it is not bonded to this nitrogen, it is in vicinity. So this imine hydrochloride is very unstable. It is on acidic hydrolysis. We get aldehyde plus NH4Cl is a byproduct. So the speciality of this reaction is we directly convert the nitriles into aldehydes. So remember, so this is a very good method of conversion of nitriles to aldehydes. Again, one example we will take. This is ethane nitrile. Again, by using reduction, stannous chloride, imine hydrochloride intermediate is prepared, and the final product is ethanol. If you take the benzonitrile, benzene cyanide, again imine hydrochloride is intermediate is formed, Cl. one hydrogen is added to this carbon, another hydrogen is added to this carbon, imine hydrochloride. After hydrolysis, we get benzaldehyde. So depending upon the nitrile, we'll get, if the benzonitrile is used, we get benzaldehyde. If ethane nitrile is used, we get ethanol. Another nitrile, if you use instead of these two nitriles, we will get the another aldehydes. So you can prepare any aldehydes by using these nitriles. And you know how the nitriles are prepared. For the nitrile preparation, we have to use alkyl halides. By using alkyl halides with the reaction of AgCN, we can prepare cyanides also. And how the alkyl halides are prepared, we can, you know the reactions, how to prepare the alkyl halides in halogen derivatives. We learn all these reactions. Means from alkanes we can prepare alkyl halides, from alkyl halides you can prepare nitriles, from nitriles you can prepare aldehydes. So all these reactions depend upon one another. So in case of Stephan reaction, another reducing agent it is used, the name of the very famous reagent is diebal H. This is actually the short form, diebal. Diebal, it is a short form of diisobutyl aluminum hydride. Remember, D for di, I for isobutyl, isobutyl. This is isobutyl aluminum hydride. It is also denoted with this AlHIBu2, isobutyl. This is di, two molecules of isobutyl aluminum hydride. This is diebal H. This is used for selective reduction. Selective reduction means if only we have to remove this only we have to do the reduction of this nitrile, and double bond we have to keep as it is, then this diebal H is used. In this nitrile, if the previous reagent stannous chloride or acyl is used, what will happen? The double bond will be also reduced. But for the reduction of only the cyanide, diebal, this diebal reagent is used. So what is the role of this diebal reagent? Double bond or triple bond present in the molecule will not be reduced. Only the nitriles will be reduced. So this is a use for selective reduction process. So for the JE purpose, NEET purpose, and board exam also, the MCQ may be asked, which specific reagent is used for selective reduction? And they may give the 4 different options. So remember, this diebal H is used for the selective reduction process, which reduce only this cyanides. Double bond, triple bond remains as it is, and we get the aldehydes here. See, CH3CH double bond CH, CH3CH double bond CH, and CH2, and this cyanide is reduced to aldehydes. So this is another reagent, diebal H, stannous chloride, and HCl. So preparation of ketones, this is the preparation of aldehydes by using nitriles. Now how the ketones are prepared by using nitriles. So for the preparation of ketones, we have to use the Grignard reagent. Directly we will take one example here. See the ethane nitrile. Ethane nitrile plus CH3MgBr, or we can take CH3MgCl. This is a Grignard reagent. You know how this Grignard reagent is prepared. When you are using Grignard reagent, always we have to use dry ether as a solvent, because this is very reactive. So the dry ether solvent it is used. First, you know, this CH3 having the minus charge, this Cl is also having the minus charge, and magnesium having the 2 delta plus. So this CH3 will attach to this carbon. This triple bond will be converted into double bond, and we'll get here minus charge, and this will attach to MgCl. So this intermediate is formed first. This intermediate, after hydrolysis, we get the ketones, and these are the byproducts, ammonia and MgClOH. These are not important, but this product is important. So make a practice at your home. You can take different nitriles here, take different alkyl halides, whatever alkyl halides you like, you can take different alkyl halides, and you can do the practice at your home. Then next reaction is preparation of aldehydes and ketones by using aromatic hydrocarbons. You know the term hydrocarbons. Once again I will explain. Hydrocarbons, these are the compounds which contains hydrogens and carbon. Such compounds are called as hydrocarbons. Preparation of aldehydes by using hydrocarbons. Now you know, if strong oxidizing agents are used, the hydrocarbons are oxidized directly to the carboxylic acid. But we didn't want carboxylic acid, we want aldehydes, so we have to stop the reaction at this aldehydic stage. So the very famous scientist Itard, who given one method to prepare aldehydes by using aromatic hydrocarbons. So we will take one example here, oxidation of methyl benzene. Methyl benzene, you know, it is also called as toluene. Toluene, this is a common name accepted by the IUPAC. Toluene means CH3 group attached to the benzene. It is called as toluene. So this toluene reacts with chromyl chloride. This is oxidizing agent. CrO2Cl2. Remember the name. First time in 12th standard we are using this chromyl chloride. CrO2Cl2. This is a chromyl chloride in presence of carbon disulfide. Carbon disulfide, the role of carbon disulfide is it is only used as a solvent here to form the chromium complex. Chromium complex is formed. So this is a chromium complex here. These two hydrogens, one hydrogen remains as it is, and another two hydrogens are included in the complex OCrOHCl2. OCrOHCl2. This complex is again hydrolyzed in presence of acid. It is called as acidic hydrolysis. H3O plus. Always remember H3O plus means it is hydrolysis by using acid. We get here benzaldehyde. So this reaction is discovered by the scientist Itard. So Itard reaction, toluene to benzaldehyde. Toluene to benzaldehyde, it is Itard reaction. Then nitrile to benzaldehyde, it is a Stephan reaction. And what is Rosenmund reaction? In which chlorides, acyl chlorides or benzoyl chlorides or acyl chlorides, these are converted into benzaldehyde. So remember these clues, how to remember the reaction. Acyl chlorides to aldehyde, it is a Rosenmund. Then for the Stephan, nitriles to aldehydes, it is Stephan. And in case of Itard reaction, toluene to benzaldehyde, this is a Itard reaction. Then oxidation of methyl benzene by using chromium oxide means the toluenes are also oxidized by using one oxidizing reagent that is called as chromium oxide. It is also called as chromium anhydride. So methyl benzene, it is taken here, it is a toluene plus CrO3 in presence of acetic anhydride. The temperature condition is 273 and 283. It is very low conditions. Temperature conditions are very low. We get again the intermediate is formed. Same intermediate like this one. Chromium complex. Chromium complex is formed by chromyl chloride, but this complex is formed by CrO3. It is the same complex like this. OCOCH3, OCOCH3. Again, acidic hydrolysis, we get benzyl. The process is same, only the complex is different here, and the reagent is different. So these are the two methods by using we can prepare aldehydes by using methyl benzene. Also, we can prepare by side chain chlorination. See, this toluene when undergoes chlorination in presence of H nu, means in bright sunlight, side chlorination of toluene gives benzyl chloride intermediate first. This is a benzyl chloride, remember. CHCl2, this is called as benzyl chloride. Again, acidic hydrolysis, we get benzaldehyde. In this, side chain chlorination takes place. Means chlorine, it is not attached to the Yes, due to internet connectivity, some problem was there. Again, we will coming to that slide. Yes, this one. So for the side chain chlorination, we have to use this uh, chlorination reaction in presence of sunlight. We get the side chain chlorination if the chlorination is done in presence of the AlCl3, that is Lewis acid catalyst. We'll get here ortho position or para position, chlorine will be attached. So we don't want that product. So for the side chain chlorination, remember, always we have to do the chlorination in presence of bright sunlight or HNU. Benzaldehyde is commercially prepared by using this method. Remember, this is the commercial method. If commercial means if you want to prepare this benzaldehyde in large proportion, we have to use this method. Then the next method is by using, the name of the reaction is Gattermann-Koch formulation reaction. You know this word formulation indicates, formulation means the formyl group we have to introduce to the reaction. So this is benzene and this is benzaldehyde. See, formyl, this is formyl group. CHO group is also called as formyl group. This formyl group is introduced in the reaction. This reaction is called as Gattermann-Koch formulation reaction. These are the name of the scientists. Gattermann and Koch, these are the two scientists discovered this method. In this method, see which catalyst has used and which reagent is used. When benzene or substituted benzene, again we can use here substituted benzene, means we can use here chlorobenzene, you can use any benzene, any substituted benzene. Aniline is there, then chlorobenzene can be substituted, then toluene can be substituted by using under high pressure with carbon monoxide. See, carbon monoxide CO is given in presence of hydrochloric acid. The catalyst is anhydrous AlCl3 or cuprous chloride CuCl to give benzaldehyde. So in one step, benzene to benzaldehyde, in one step we can prepare this benzene to benzaldehyde. So again, it is a very important reaction. Name reaction, this is as for 2 marks, Gattermann-Koch formulation reaction, or it is also called as Gattermann-Koch reactions, benzene to benzaldehyde. Now, before this, many reactions are completed: Stephan reaction, Itard reaction, then Rosenman reaction. All these reactions, for the practice of this reaction, prepare one chart. In the chart, we have to prepare the columns. First one is reactant, second one is reagent or catalyst, and third one is product. So prepare the chart like this. Chart wise, we have to remember the reactions. 10 minutes are remaining. And by using this chart, we can remember this reaction. Otherwise, it is very difficult to remember this reaction. This chapter having the 8 marks weightage. If you prepare this chapter very well, you will get 8 out of 8 marks, because all the reactions will be asked from this chapter. No any mechanism will be asked from this year for the board exam. So it is a good news for all students. No any mechanism will be asked for the board exam from this year. So all the mechanisms are reduced. The mechanism of SN1 reaction, NSN2 reaction, it will be not asked for exam. Then the mechanism of aldol condensation reaction is also reduced from this chapter. So whatever the part I am teaching at the time of lecture, it will be asked for exam. Remember. So I will not remind you again and again which part is deleted, which part is non-evaluative for the board exam. At the time of teaching, simultaneously I will explain which part is not for exam, which is asked for board exam. So this next method is preparation of aldehydes from esters. So directly we will take the example of this. Is one ester is given here. The name of the ester is ethyl undecanoate. You know, I think you know how to give the IUPAC names of the esters. First, we have to take the group attached to the oxygen. It is C2H5. C2H5, this is ethyl. Undecanoate means I think there are 11 carbon should be there. So this is carbon number 1. These are the 9 carbons. This is 9 plus 1, 10, and 10 plus 1, 11. So 11 carbons are there. That's why it is called as undecanoate. Remember, undecanoate. If 10 carbons are there, it will be decanoate. If 9 carbons are there, it will be nonate, like this. Methanoate, ethanoate, then butanoate, pentanoate, like this. This is undecanoate. So this ester having the ethyl group plus 11 carbons here, we get yes, in presence of the catalyst diol H. Remember, this diol H is also used in one reaction. The name of the reaction is Stephan reaction. In this Stephan reaction, this diol H is used, diisobutyl aluminum hydride, for the selective reduction. So by using this diol H, undecanal it is prepared. By one step, you can prepare this ester to aldehydes by using this diol H. So again, this is a very important reaction. This reaction is carried out at very low temperature, 195 K, and it is very difficult to carry out this reaction because 195 K temperature maintaining is very difficult. So you must know how the esters are converted into aldehydes. Then this is today's homework. If you solve this homework, the practice of these reactions will be automatically done. So remember this reaction. This is alkynes, Hg2 plus H2SO4. This is a method of preparation of aldehydes by using hydrocarbons. Then this is a method of preparation of ketones by using dialkyl cadmium. This is also explained. This is a very famous reaction. Identify the reaction. I will not give the hint. Say this is benzene and this is anhydrous AlCl3. It is very easy to. This is Friedel-Crafts reaction. I will not give the hint because this is homework for you. Try this homework. If you didn't know the answers, then call me. I will give the answers. So these are the very nice questions I have taken from the different books. Yes, this is CrO2Cl2 H3O plus. By using the reagent, also you can identify the reactions. CrO2Cl2 means this is a very famous Itard reaction. Oxidation of toluene takes place, chromium complex, and this chromium complex, after hydrolysis, we get aldehydes. Then identify the reagents required to achieve each of the following conversion. So conversion reactant and products are given here. This is a benzyl chloride to benzaldehyde. It is very famous reaction. First, I explained this reaction. This is a Rosenmund reaction. This is nitrile CN, CN. Sorry, this is a alkynes are there. Alkynes to benzaldehyde, and this is a COOCH3 to benzaldehyde. This is esters. This is esters to benzaldehyde. So all these reactions I have already explained. Then the next part is methods of preparation of carboxylic acids. Again, you know the carboxylic acids. These are the carbonyl compounds. The difference between aldehyde ketones and carboxylic acids is aldehyde is having COH functional group, ketone having only CO functional group, and this carboxylic acid having the COOH functional group. So first method of preparation of preparation of carboxylic acids by using nitriles and amides. Now you know these two functional groups, what is nitriles and what is amides. So first we will discuss one example. Alkyl nitriles are aryl nitriles. Alkyl means aliphatic and aryl means aromatic nitriles. On acidic hydrolysis gives amides first. So amides, these are the functional groups having RCONH2, this one. So this amide is formed first. Amides on further hydrolysis gives carboxylic acids. This hydrolysis is carried out by using dilute mineral acids like H2SO4 or HCl. So without example, it is very difficult to understand the reactions. Directly, we will take one example first. So this is a nitrile, general nitrile plus H2O. On hydrolysis, we get intermediate here. And this intermediate after tautomerization, we get amides. Means amides, it is the first one, first product. After hydrolysis, they give carboxylic acids. So this is a simple hydrolysis. Hydrogen and OH is attached here. Hydrogen attached to here. This is negative part. This addition of H2O is according to the Markovnikov's rule. Remember here. This hydrogen is added to the nitrogen and OH is attached to the carbon atom, which contains less number of hydrogens. We get first this intermediate. After tautomerization, this hydrogen is shifted. Hydrogen is shifted and amides are formed. Amides again can give these intermediates, so that's why the reversible arrow is shown. So amides are stable. Amides are unstable. They can give this intermediate back. So amides on hydrolysis, they give the carboxylic acids. One important example is taken here. So see, this is a ethanamide. Direct amides are taken here. Amides. This step is not given. Directly amides are taken. So that's why in the title of the reaction it is given from nitriles and amides. From the nitriles, amides are prepared, and amides are after hydrolysis gives carboxylic acids. So this amide is taken after hydrolysis. They give ethanoic acid plus ammonia. Again, this in case of benzamide, gives benzoic acid plus ammonia. But how these are prepared? These are prepared by using nitriles. So the previous step you should know how these amides are prepared. Amides are prepared by using nitriles. That's why the first step is shown here. Then next one, preparation of carboxylic acids by using acid chlorides. So by using these acyl chlorides, you can prepare aldehydes. By this acyl chloride, you can prepare the ketones. By this acyl chloride, you can prepare the carboxylic acids. So only 1 minute is remaining. I will stop here. So my kind request to all students, this is organic chemistry. Daily we have to do the revision. So the next lecture will be start at 9:30 again. So we will stop here.